C99 tutorial part 3. Let's open the far.c program from last time and look at a solution to the problem. We were supposed to add command line arguments for lower, upper, and step. And you see here I've used a feature called pound define. This is similar to pound include. These commands are called preprocessor directives, and they're different from normal C statements. Notice that in C, statements always end with a semicolon at the end of the statement. The reason for that is C is considered a free format language. That means you're allowed to write in as much or as little white space in between tokens as you like. For example, if we'd like, we can split a line into multiple lines, and we could, for example, we could space this out like this. And so when the compiler starts reading a statement, it won't stop until it gets to a semicolon, or to a closing brace. However, preprocessor directives should always be on one line. The preprocessor ends at the end of the line. Alright, so what is the purpose of pound define? When we use pound define, it's like a variable, but we're defining a new symbol that we can use for our convenience, called lower. And I've written it in all uppercase. Notice that C is a case-sensitive language, so if we write something in uppercase or small letters, it becomes an actual different symbol. And it's not a requirement, but there's a convention that programmers use all uppercase for such preprocessor symbols. The three ones we define are lower, upper, and step. Lower is simply a synonym for argv1, which is argument 1. Lower is argv2, and step is argv3. Using the preprocessor this way allows us to define names for things that we're going to type. For example, instead of typing argv1, I can type lower. And the preprocessor will essentially go through and do a copy and paste on these items. Lower, upper, and step. So what's the point of this, you might ask? We could have just typed in argv1, argv2, argv3. After all, we know that those arguments correspond to those parameters. But it turns out in a larger program, this type of documentation will become very useful, because then we can combine all of these symbols together into one place, and those become our configuration for the project. So just to get into a good habit, I'll try to use this kind of preprocessor directive anytime we have a value which could be hard-coded but possibly later changed. So what are the type of these symbols? Lower, upper, and step. If we go up here, you'll notice this is char star, and remember char star is another name in C for a string. We want to use these strings as a number. The function to convert it is A to F. This will convert a string into a double. And I always remember the name by thinking this is ASCII to floating point. So it's converting an ASCII string to floating point values, which are double in C. And so after converting the strings, we're storing them in our variables, which are written with small letters. Again, this is just a convention, it's not required. So now let's compile and run and see how it works. So first copy the command line, and then let's paste it into our command prompt. So let's move into the desktop and try it out. So my example is far 0, 320. And so it produces the same table as before. Let's try a different step size, try 18. And you'll notice the table is increasing by 18 each time. Now let's try something negative, maybe with a decimal point. So minus 300.5. 427.2501. It's important to think of tricky inputs. Okay, 29.999. Let's do that. And so when we run it, then we get our result. So it seems to be working fine. However, there's one slight problem here. Suppose I run the program with no arguments. So I just run far, but I don't specify lower, upper, or step. What will happen? Notice in our program we've specifically said what the arguments should be. Let's try it with no arguments. So I get an error message from Windows. The instruction at 0x77C1CF9F referenced memory at 0x00000. The memory could not be read. Click OK to terminate the program. So this result shows one of the less friendly parts of the C language, namely undefined behavior. So let's consider this parameter argv. argv1 is a string, and presumably the string could have any value if we didn't give it a value already. However, if we go here, we're assuming in our code that we have 3 strings, and we're trying to convert them into doubles. So how can we fix it? Let's look at this, argc. It turns out argc stands for argument count, and it's the number of arguments that are passed to the command line. And remember, the command itself counts as an argument. So if I just type far, then I expect argc has a value of 1. And if I write command far 0320, so now what should argc be? It should be 4, because I have 1, 2, 3, 4 command line arguments. And so let's do a simple fix. The simple fix is, before we do this part, let's do an additional step. I'll call it verify arguments. So normally command line tools give some kind of usage for what arguments they're expecting. For example, go to GCC and you'll notice its usage is as follows. Type in GCC and then -- help, and this will show the usage of GCC. And there's a lot here, but scroll up and you'll see the basic usage at the top. So the basic usage is GCC options file. And when you're reading the usage like this, normally the brackets around some part, like options, means that this part is optional. So you can give it an option, but you don't have to. So the basic example is gcc far.c. Far.c in this case is a file. However, before the file, we can give it options. And one example is -wall for warnings, and the other is -wearer for turning on errors on warnings. And of course, -o is the output file name. So that summarizes GCC. Let's use the same idea in our far program. Our usage would be like this: far, lower, upper, step. So in other words, argc should be equal to 4. Let's do a test to see if this is true. If argc not equal to 4, and if that's true, then we'll produce an error message. So here's what the error message should look like. And for our error message, let's just use the usage of the program. Type a new line, and then at this point I want to break the program. So I'm going to use the command exit. And the exit function has one argument, which is the return code. And remember, the return code 0 signifies no error. So in this case, let's give it 1 as the error code. So 1 means there's some problem. Save the program and let's try it out. And so now what happens? If I just type far, then I get the usage. Or if I type far 0, it's still not enough arguments, so I get the usage again. Far 0300, far 0320. Okay. Far 0320 -1. So basically we're doing our own check of the command line arguments. If the count is wrong, then we're going to show an error message and then exit the program.